I won the Nobel Prize for something that sounds completely insane. Stockholm, 1965. I am standing in a hall full of kings and queens and distinguished scientists in fancy clothes. They are about to give me the most prestigious award in all of science. And the discovery they are honoring me for is this: a positron is an electron traveling backward through time. Not metaphorically, not poetically, not as some sort of mathematical trick or convenient fiction. I mean it literally. The antimatter particle that Paul Dirac discovered in 1928, the particle that Carl Anderson photographed in 1932, the particle that has mystified physicists for decades. That particle is simply an ordinary electron moving in the wrong direction through the fourth dimension. When they announced this in Stockholm, when they explained why I was receiving the prize, I wondered how many people in that audience thought the Nobel Committee had finally lost its mind. But they had not lost their minds, and I had not lost mine. The mathematics is airtight. The predictions match experiments to 12 decimal places. The entire framework of quantum electrodynamics, the most accurate theory in the history of science, is built on this single, ridiculous-sounding idea. Antimatter is not anti-anything. Antimatter is just matter running the movie in reverse. Let me show you how I figured this out. Let me show you why it has to be true, and let me show you what it means about the nature of time itself. To understand antimatter, you first have to understand what a positron is. And to understand what a positron is, you have to understand why anyone went looking for it in the first place. In 1928, a quiet British physicist named Paul Dirac was trying to do something simple. He was trying to write an equation for the electron that was consistent with Einstein's special relativity. Before Dirac, we had Schrödinger's equation, which described how electrons behave in atoms. Beautiful equation, worked perfectly. One problem: it did not account for the fact that nothing can travel faster than light. Dirac wanted to fix this. He wanted an equation that obeyed the rules of relativity. So he sat down and did the mathematics. What came out terrified him. His equation had two solutions. One solution described an electron with negative charge and positive energy. That was fine. That was what he was looking for. That was the electron we all know and love. But the other solution described something else. A particle with the same mass as the electron, but with positive charge. And this particle seemed to have negative energy. Negative energy. What does that even mean? A particle with less than zero energy? A particle that would fall upward? A particle that would give you energy by taking it away? Dirac did not know what to do with this. He tried to ignore it. He tried to explain it away. He suggested that maybe all these negative energy states were already filled, like seats in a theater, and so we would never notice them. He called this the Dirac Sea. It was a desperate idea, an ugly idea. But Dirac was stuck with it because his equation demanded it. And then 4 years later, Carl Anderson was studying cosmic rays with a cloud chamber. Cosmic rays are high-energy particles that rain down on Earth from space. When they pass through a cloud chamber, they leave trails of condensation, like jet contrails in the sky. You can photograph these trails and figure out what kind of particle made them. Anderson saw a trail that looked exactly like an electron, same curvature, same mass, but it curved the wrong way in the magnetic field. Instead of bending left, it bent right. Instead of negative charge, it had positive charge. He had found Dirac's impossible particle. He had found the positron. He had found antimatter. The Nobel Prize in 1936 went to Anderson for the discovery, but nobody understood what the positron really was. Nobody understood why it existed. Nobody understood what Dirac's equation was actually telling us. That puzzle sat there for 15 years until I found the answer. The answer came to me in graduate school in the early 1940s. I was working on quantum electrodynamics, trying to figure out how electrons interact with light. The calculations were nightmarish, infinities everywhere. Every time you tried to compute something simple, like how an electron scatters a photon, you got infinity as the answer. Infinity is not an answer. Infinity is a cry for help. I spent months staring at these calculations, rearranging them, drawing pictures of them, trying to see patterns that others had missed. And one day I saw it. I was drawing diagrams, little pictures showing electrons moving through space and time. An electron starts here, moves forward in time, emits a photon, moves forward some more, absorbs another photon, continues on. These pictures were helping me organize the calculations. And then I drew a positron. I drew its path through space and time, just like I had drawn the electron, but something looked wrong. The positron was moving forward in time, just like the electron. It was doing the same things, interacting the same ways, and yet, mathematically, it was different. The charge was opposite. The equations had minus signs, where the electron had plus signs. Why? I stared at that diagram for a long time, and then I did something that seemed crazy. I rotated it. I took the positron's path through space-time, and I flipped it. I reversed the direction of time. Instead of moving from past to future, I drew it moving from future to past, and the minus signs disappeared. Let me explain what I saw, because this is the moment everything changed. When an electron moves forward in time, it carries negative charge in the forward direction. That is just what an electron is. Negative charge moving through time from yesterday to today to tomorrow. Now imagine you could film an electron, a little movie showing the electron traveling through space and time. You run the movie forward and you see a negative charge moving forward. Normal, expected, nothing strange. Now run the movie backward. The electron is still there. It still has negative charge, but now it is moving backward through time. It is going from tomorrow to today to yesterday. Here is the question that haunted me. What does a negative charge moving backward through time look like to someone who is stuck moving forward through time? What does it look like to us? Think about it carefully. The electron has negative charge. It is moving backward. From our perspective, from our forward moving point of view, what do we see? We see positive charge moving forward, not because the charge changed. The charge is still negative, but the direction reversed. And negative going backward is mathematically identical to positive going forward. This is not a trick. This is not an approximation. This is exact. The equations are the same. The physics is the same. There is no experiment you can do, no measurement you can make that can tell the difference between a positron moving forward through time and an electron moving backward through time. They are the same thing. Let me give you an analogy. Imagine you are standing on a sidewalk watching traffic. Cars are driving past you, going from left to right. You count them. Red car going right, blue car going right, green car going right. Now suppose one car is driving backward, a yellow car in reverse gear, moving from right to left. What do you see? You see a car going left. You do not care that the driver is facing the wrong way. You do not care that the gear is in reverse. From your point of view as a person counting traffic, a car going backward to the right is the same as a car going forward to the left. Direction of motion is what matters, not how the internal machinery is oriented. Time works the same way. An electron with negative charge moving backward through time is indistinguishable from a particle with positive charge moving forward through time. The internal machinery, the negative charge, is oriented backward, but the motion we observe is forward, and forward motion of reverse charge equals positive charge. The positron is not a new particle. The positron is the electron running in reverse. Now let me show you why this matters. Let me show you what this explains. You know what happens when an electron meets a positron? They annihilate. They collide, they vanish, and they release energy in the form of 2 gamma-ray photons. 2 particles go in, 0 particles come out. Mass converts to energy. Einstein's famous equation in action. But in my picture, what is really happening? There is only 1 particle, the electron. The electron is moving forward through time. It reaches a point in space-time, a particular place at a particular moment. Something happens. A photon arrives maybe. Some interaction occurs, and the electron reverses. It starts moving backward through time. From our perspective, stuck in our forward-moving present, we see 2 things approaching each other. We see the electron coming from the past. We see the positron coming from the future. They meet at the reversal point. They seem to annihilate. But nothing is annihilated. Nothing is destroyed. The electron just turned around. It was going forward. Now it is going backward. The apparent destruction is an illusion created by our limited perspective on time, and the reverse process, pair creation, where energy transforms into an electron and a positron, that is also a turnaround. The electron is moving backward through time, approaching a certain point. It reaches that point and reverses. Now it is moving forward. From our perspective, we see a photon disappear and 2 particles appear. An electron going one way, a positron going the other way. Creation from nothing, matter from energy. But it is not creation. It is not something from nothing. It is 1 particle bouncing off a point in time, reversing direction. Every creation is a turn. Every annihilation is a turn. The electron zigzags through space-time, and we poor creatures trapped in the present moment see only snapshots. We count the snapshots as separate particles. We give them different names: electron, positron, matter, antimatter. But there is no antimatter. There is only matter moving in different directions through time. This idea gave me a tool, a way of calculating things that had been impossible before. When I drew my diagrams, the pictures that are now called Feynman diagrams, I used this principle. Every line in the diagram is a particle moving through space-time. Lines going upward represent particles moving forward in time. Lines going downward represent particles moving backward in time. But here is the beauty. A line going downward, a particle moving backward in time, is mathematically the same as its antiparticle moving forward in time. So I can draw any process, any interaction, any collision or decay or creation or annihilation using just 1 rule. Particles move through space-time. Sometimes they emit or absorb other particles. Sometimes they reverse direction in time. That is it. That is the whole picture. With this tool, I could calculate things that had been giving physicists nightmares for decades. The interaction of electrons with light, the scattering of photons, the magnetic moment of the electron, the probabilities of particle processes, and the calculations worked. They matched experiments, not approximately, not roughly, to 12 decimal places. 12, the most accurate predictions in the history of science. The idea that antimatter is matter going backward through time is not philosophy. It is not speculation. It is the foundation of the most precise and successful theory physics has ever produced. That is why they gave me the Nobel Prize. Now I want to tell you what this means, not just for physics, for reality, for your understanding of what time actually is. We think of time as a river flowing in one direction, from past to future, from birth to death, from beginning to end. We experience time this way. We remember yesterday, but not tomorrow. We can affect the future, but not the past. The arrow of time seems obvious, seems fundamental, seems built into the fabric of existence itself, but the equations do not agree. The fundamental equations of physics, the deep laws that govern particles and fields and forces, they do not care which direction time flows. Run the equations forward, you get valid physics. Run the equations backward, you get equally valid physics. The mathematics treats past and future as interchangeable. This is called time reversal symmetry, and it is one of the most disturbing features of fundamental physics. If the laws of physics work the same backward as forward, why does time seem to flow only one way? Why do we remember the past and not the future? Why do eggs break but never unbreak? Why does ice melt but never unmelt? These questions have haunted physicists for over a century. We have partial answers involving entropy and thermodynamics and the statistical behavior of large numbers of particles. But at the deepest level, at the level of individual electrons and photons and quarks, time has no preferred direction. The positron is proof of this. The positron exists because the equations of physics work backward. Dirac's equation has two solutions because time can run two ways. The positron is the electron's mirror image in time, and the fact that it exists, the fact that we can create it and study it and photograph it, tells us something profound. Time is not what we think it is. Let me push this further. Let me show you where this logic leads. If a positron is an electron going backward through time, what is an antiproton? A proton going backward through time. What is an antineutron? A neutron going backward through time. What is antimatter? Matter going backward through time. And what would a whole atom of antimatter be? An antihydrogen atom with an antiproton at the center and a positron orbiting it. It would be a hydrogen atom going backward through time, a tiny piece of ordinary matter reversed in its relationship to the fourth dimension. We have made these atoms. We have created antihydrogen in the laboratory. We have trapped it in magnetic bottles and studied its properties. And everything we have measured confirms the theory. Antihydrogen behaves exactly like hydrogen, with all the signs reversed in exactly the ways the equations predict. The antimatter is not exotic. The antimatter is not mysterious. The antimatter is us in a mirror not of space, but of time. There is a story I like to tell about this. It is a thought experiment, not a real experiment, but it captures something important. Imagine you receive a message from an alien civilization. They want to meet. They are sending a spaceship. But before they arrive, they want to make sure there will be no misunderstandings. So they ask you a question. They ask you to describe yourself, left and right, up and down, forward and backward. They want to know how you are oriented so they can match their spaceship to your docking port. You describe left and right. You tell them about your heart being on the left side of your body. But wait, how do you know their left is your left? Maybe they use the opposite convention. Maybe their left is your right. You try again. You describe the rotation of the Earth. But maybe their planet rotates the opposite way. You describe the spin of electrons. But how do you know they measure spin the same way? This is a real problem. It is called the Ozma problem, named after a project to communicate with aliens. How do you communicate left and right with someone who might have opposite conventions? There is a solution. You can use certain particle physics processes, certain weak nuclear decays that violate left-right symmetry. By describing these processes, you can establish an absolute definition of left and right that any physicist anywhere in the universe would agree on. Problem solved. Left and right are no longer ambiguous. But now imagine a deeper problem. Imagine the aliens are made of antimatter. They look like us. They think like us. They have hearts and brains and fingers and toes. But every particle in their body is the antiparticle of the corresponding particle in our body. Positrons instead of electrons. Antiprotons instead of protons. Antineutrons instead of neutrons. If they land on Earth and shake hands with the human, both would annihilate. A burst of gamma rays, total destruction, the handshake of death. Now here is the disturbing part. From the aliens' perspective, they are made of matter. We are made of antimatter. There is no absolute standard. There is no cosmic label that says this is matter and that is antimatter. It is all relative. And if antimatter is just matter going backward through time, what does that mean for the aliens? It means that from our perspective, the aliens are traveling backward through time. Their past is our future. Their future is our past. Their cause is our effect. Their effect is our cause. If we could somehow communicate with them without annihilating, we would find that they remember things that have not happened yet and cannot remember things that have already happened. To them, we would seem equally bizarre. This is what the equations imply. This is where the logic leads. I do not know if antimatter civilizations exist. I do not know if it is possible for complex structures to form and evolve in a time-reversed manner, but the physics does not forbid it. I started this talk in Stockholm in 1965, receiving a prize for an idea that sounds insane. Antimatter is matter going backward through time. It sounds like science fiction. It sounds like philosophy. It sounds like the kind of thing a physicist says after too much wine at a dinner party. But it is true. It is the foundation of quantum electrodynamics. It is the reason my diagrams work. It is the explanation for why positrons exist, why they have the properties they have, why they annihilate with electrons in exactly the way they do. The universe is stranger than we imagine. The universe is stranger than we can imagine. Time is not a river flowing in one direction. Time is a dimension like space, and particles can move through it in either direction. We are trapped in the forward direction. Our brains are built to process cause before effect. Our memories work in one direction only. We cannot experience backward time any more than a fish can experience dry land. But the particles inside us are not so limited. The electrons in your body do not know which way time is supposed to flow. The equations that govern them work equally well forward and backward. And sometimes in particle collisions, in high-energy experiments, we catch glimpses of what backward looks like. It looks like antimatter. It looks like positrons and antiprotons and antineutrons. It looks like the mirror image of everything we know. That is what I discovered. That is what won me the Nobel Prize. That is what I am trying to explain to you now. Antimatter is not strange. Antimatter is familiar. Antimatter is us, reflected in the mirror of time. And somewhere out there in the equations that govern the universe, a positron is just an electron that turned around and went home.